Hey everyone. Today I want to talk a bit more about a concept that was introduced in maybe many different talks yesterday. Probably heard of this buzzword called Omni Bridge being mentioned a number of times. And here I just want to do somewhat technical deep dive on how things work and why it would be useful. Okay, so what are some of the problems with bridges today? I mean, to be fair, one of the problems is there are too many of them. But more realistically, it's oftentimes not very easy to use. As a developer, you need to understand, well, there's a new bridge and some new API that I need to integrate with, and so on and so forth. And also, it doesn't, most of the bridges don't actually support non-smart contract chains, and usually how it works is that there may be some smart contract on the different chains, and then you can prove things about other chain with the bridge. But for non-smart contract chains, sometimes that doesn't work very well. So what Omni Bridge wants to do is that it wants to provide a unified interface that developers can easily integrate with and make a great experience for the users as a result. And we also want to make sure that it can work well with non-smart contract chains, so most notably Bitcoin. So this is kind of an overview of what the interface looks like. I think I would say the most important part here is this Omni transfer, which is so this, what is shown here is basically this client-side SDK, right? So it's not smart contract. So basically on this client, so the Omni Bridge, we don't actually introduce any new standard per se that's on chain. Rather, you as a developer, you can just use this SDK and do Omni transfer, and it can basically take a variety of chains or like accounts on different chains as parameters. And also in this transfer message, basically you just say, okay, here is my account on some chain, and I want to transfer to another chain, and this is the amount I want to transfer, and this is the amount of fee I want to pay for this transfer. And it basically would just automatically work. You can just call this. Well, obviously, you need to wait for a bit, right? Because as we know, bridge is not instantaneous. It's an asynchronous operation, but you just call it and wait, and then magically it will be done. So looking at the example more concretely, so let's say you want to transfer from ETH to Base, and then what you basically just do is that you obviously get your wallet, and then you say like, okay, here is the address I have, and here is how much tokens I want to transfer, and the recipient address, and also the fee I want to pay for this transfer to happen, and then you just call Omni transfer, and it's done. So it's basically a very, hopefully very easy to understand and very easy to use interface for developers so that we can provide a seamless experience for users to move their assets across different chains. Now, obviously, there's a question, well, how does it actually work? So there are too much text here, but basically I just want to give an example of how you move assets from, let's say, Near to Ethereum, and also move from Ethereum to Near. So the important thing to note here is that they're not asymmetric. They're not symmetric, meaning that the way you do transfer from Near to destination chain is not the same as you do from destination chain to Near. So basically from Near to Ethereum, for example, it's done through chain signatures. Basically, there's token locker contract on Near has a corresponding derivation address on Ethereum so that it can sign Ethereum transactions. What it actually signs is not the Ethereum transaction per se, but it gets verified on Ethereum, and then the contract there can mint the corresponding tokens in the ERC20 contract. And conversely, when you want to bridge from Ethereum to Near, what you're doing is actually doing light client proof. So this is similar to what we already have for Rainbow Bridge. So it's the similar concept. And for Bitcoins, yeah, it's basically the same thing, that the way we support Bitcoin is that the contract on Near will have a derivation address on Bitcoin that people can deposit into, and then proof can be verified. Then on Near, corresponding tokens get minted. And if one withdraw to Bitcoin, then because contract has address on Bitcoin, then it can sign a transaction that's going to get executed on Bitcoin. Obviously, it's not going to be very fast, but well, that's just the withdrawal on Bitcoin that you have to deal with. So yeah, here, as I was working through the example in Ethereum and Bitcoin, I think this asymmetry is manifested in this two important components that underpins Omni Bridge. One is called chain signatures, as many of you are probably familiar with. It's this ability, well, the chain signatures allow near smart contracts to have derivation addresses on many other different blockchains, and as a result, they can actually sign transactions on other blockchains, so that the withdrawal is basically this smart contract actually sign the transaction that can get executed on other chains, so that it's kind of a bridging which is not an actual bridge, and because it's all native to other chains. And in the other direction, we basically create this abstraction called Omniprover. It is this abstraction that can prove transactions on Near, can prove transactions on other chains on Near, so that we can be convinced, so smart contracts on Near can be convinced of transactions that happen on other chains. Now, obviously, there are many different ways you can do this, so that's why it is an abstraction. Actually, depending on the chain that we use, that we interact with, the actual prover is different. So this is kind of like a router. Let's say an Ethereum proof comes in, it would know from the address that is Ethereum transaction, and then it will route to this Ethereum Lite client that can verify the transaction, verify the proof that some transaction has happened on Ethereum. And similarly with Bitcoin, there's Bitcoin Lite client that would verify the transaction. But Lite client is not always feasible to implement, or not always the most convenient thing to implement if we want to support many different chains. So the Omniprover also integrates with other message passing protocols like Wormhole that would also provide this proofs for different blockchains. And finally, an important piece here is the relayer, right? Because what we talked about so far are just mostly about smart contracts, and smart contracts, they cannot act autonomously. So right, you actually need someone to submit the proofs and trigger the execution on the other side to actually finish this moving of assets. And the relayer is used to do that. And the important thing here is that anyone can run a relayer. It's completely trustless. It doesn't introduce any point of centralization. And also in the if we go back, in the API, there is actually a fee that you can specify to pay for the relayer, so that it's not so that relayers are incentivized to work. And that obviously is great kind of technical ideas, but we also are working very hard on bringing them to reality. We want to support more and more chains in the future, but there are an initial set of chains that we want to support. There'll be Near, Bitcoin, Ethereum, Solana, Base, and Arbitrum. And we hope to launch that in Q1 2025. And then as developers, you can build on top of that, make it very easy for people to move assets, especially fungible tokens, across those chains with no hurdles. So yeah, that's a quick overview of how Omni Bridge works. And yeah, thanks everyone for listening.